All right, so we just did this example where we had a force going the direction we were going. So the force was going the same direction of motion, and then all the work we did counted, which is usually not true. Usually we're in this case, where the guy's pulling the box and not everything counts. He's pulling up a little bit, and it's not quite that efficient. So let's just write down a number. So if you put this into a calculator, this is about 27.9. We didn't give units, but sometimes work is in joules, which are Newton meters. May or may not be in joules in this case. Okay, so let's just keep that in mind, and then let's do a line integral. So our first line integral was this function in the direction we're going. That's what ds means. But maybe we don't care about that direction. Maybe we only care about the x direction. So how do we do that? Well, same principle. We wrote for ds, we found ds by dt and then figured out what ds was. So this time we'll write dx by dt. Okay, well that's a lot easier. Dx by dt is just x prime of t. So then dx should be equal to x prime of t dt. So this formula should be the integral from the first to the last t value of f of xyz times x prime of t dt. Okay, so let's use the same function and movement vector we were using, the same example as up here. And now, so instead of this r prime, we're just going to put x prime, so derivative of sine, which is cosine. So everything's the same. My f of r of t is still t. So I get integral from 0 to 2 pi, and check this out more slowly if you need to, t, and then the derivative of sine is cosine t dt, and this is a quick integration by parts. So you can write out u's and b's if you want, but basically you're going to integrate one thing and then subtract, and then we're going to keep the thing we integrated and take the derivative of the other thing, which is 1 dt. Okay, cool. And then plugging in 2 pi into here, well, sine of 2 pi and sine of 0 are 0, so that's all 0. And then we're going to integrate, integral of negative sine t is positive cosine t, so that's cosine t going from 0 to 2 pi. Oh, but that's weird. So cosine of 2 pi is 1 and cosine of 0 is 1. So you get 1 minus 1, and then you get a total of 0. Okay, so what happened here? Let's think about this. If you only cared about going in the x direction, maybe you shouldn't have been traveling along this helix, because this helix goes around and you end up in the exact same place as you started in the x direction. So that's what we calculated here, is if we went one time around the helix, how much work did we do to get us somewhere else in the x direction? None at all. That was 0.